Okay, hi students, friends. Now we will see the next practical, that is practical number 7. Calibration of broad-crested suppressed weir. Okay, write on the title. Calibration of broad-crested suppressed weir. Title is written, then N, to determine coefficient of discharge for of broad-crested weir, suppressed weir. So in the theory, we have learned what is the meaning of weir, then what is broad-crested weir, then what is suppressed weir, or weir without end contraction, right? So let us revise that concept and go ahead. So when we call the weir as a uh, thin plate weir, narrow crested weir, or broad crested weir, so it depends upon the value of head of the water above the crest and the length of the crest, okay, or the that width of the crest, not length, width of the crest. As you can see in the diagram, how much is the width of that crest is that it shows shown by the capital letter B, and head of the water above the crest. If the value of H is much greater than the value of width of the crest, then we call it as a thin plate weir. In other words, if the ratio H by B, if it is greater than 1.6, then we call it as a thin plate weir. Okay. So in that case, the thickness of this plate will be very small. Plate, or we can say it's weir. This may be the thickness, and this must be the value of B. Okay, and this head will be much more than this H will be much more than this B. Okay, so if I take this H by B ratio, then it will be greater than 1.6. Then comes the narrow crested weir. If this H by B ratio, in this case now, it has become somewhat larger. Okay, थोड़ा ही मोठं होतं. Thickness या ठिकाणी वाढतो. ठीक आहे. H by B ratio, it is greater than 0.4 but less than 1.6. In that case, we call the weir as a narrow crested weir. And if the H by B ratio, now it has become less than 1, okay, in both cases. If it is greater than 0.1 but smaller than 0.4, means now H value has become reduced and B value is increased. म्हणजे हा याच्यापेक्षा हाईट पेक्षा हे जे B आहे ते जास्त झाले या ठिकाणी. So that is called as the broad crested weir. Broad crested weir. Now in this broad crested weir, there will be two heights, two heads will be there. One head before water entering or coming onto the weir crest. Weir crest च्या याच्या अगोदर हे पाण्याची हाईट असते कॅपिटल H, आणि crestच्या वरती जी हाईट आहे that is called as the small h. It has been written as small h. Why there is this reduction in the height is there? Because when water comes here on this crested weir, broad crested weir, at that time its velocity increases, and we know that to maintain the continued equation a1 v1 equal to a2 v2, now this area, this velocity is increased. So what should happen to the area? Area has to be reduced. So the width तर सेमच आहे, त्यामुळे हाईट मध्ये त्या ठिकाणी काय होते, डिफरन्स होते, कमी होते, आणि आपल्या या ठिकाणी हे स्मॉल h या ठिकाणी भेटते. So this was about the weirs, types of the weirs. Suppressed weir and weir without end contraction and weir with end contraction. So that also we have studied in theory. So in the diagram here you can see the first one is the contracted rectangular weir, okay, or weir with end contraction. त्याला दोन एंड कॉन्ट्रॅक्शन प्रोव्हाइड केलेले आहेत. एंड कॉन्ट्रॅक्शन जर असेल त्या केसमध्ये आपला फॉर्म्युला वेगळा असेल. जसं आपण फ्रान्सिस फॉर्म्युला पाहिलेला आहे, त्याच्यामध्ये वी हॅव नोटेड डाऊन देअर लेंथ जी आहे ते लेंथचं काय होतं त्या ठिकाणी, लेंथ रिड्यूस होते बाय हाऊ मच अमाउंट, 0.1 into n into capital H. So this small n is nothing but it is number of end contraction. तर या केसमध्ये दोन एंड कॉन्ट्रॅक्शन असतील तर या ठिकाणी 0.1 multiplied by 2 we have to do here. That much length will be reduced, right? And suppressed rectangular weir, तेव्हा ह्याला आपण म्हणतो weir without end contraction. या ठिकाणी end contraction नाही आहे. ओके, सो अशा टाइपचा जो weir आहे त्याच्यावरती आपण आज या ठिकाणी प्रॅक्टिकल करणार आहोत. वी आर गोइंग टू फाइंड आउट द कॉन्स्टंट्स ऑफ दिस पर्टिक्युलर weir. This is the experimental setup. Here you can see broad crested weir has been put in the tilting plume. Okay, and note down the observations and observation table for this practical. Observations first. Area of the collecting tank. It is same to the previous practical because this practical also we are going to perform on the same tilting plume. So the cross section area of the collecting tank will be capital A is equal to 0.4 by 1 is equal to 0.4 meters square. Width of the weir or channel will be same. L is equal to 0.15 meter or 150 mm. Initial reading, it will be different than the previous one because the height of the V notch, it may be different than the rectangular notch or weir. So here H1 reading is equal to 0.196 meter. Observation table is somewhat bigger. You can make it on the making paper horizontal. जर उभं बसत असेल तर आडवं त्या ठिकाणी तुम्ही टेबल तयार करा. Serial number, point gauge reading H2, capital H2, small h2. The head of the water over the weir, Ogi weir, capital H is equal to and small h is equal to difference in the heads, that is capital H minus small h, rise of water in the tank, delta H, volume of water collected in the tank, time required, and actual discharge. With the help of point gauge, what are the different readings we are going to take there? So that should be known to you. Capital H2, हे final reading आहे. See here, हा broad crested weir आहे. या ठिकाणी पाण्याची लेवल जास्त असेल पर ती थोडी कमी होईल या ठिकाणी असेल. ही जी हाईट आहे फ्रॉम द क्रेस्ट दॅट इज नथिंग बट कॅपिटल एच. हे कॅपिटल एच काढण्यासाठी आपल्याला इनिशियल रिडिंग आणि फायनल रिडिंग माहित पाहिजे. इनिशियल रिडिंग आपण या ठिकाणी काढलेलं आहे H1. ठीक आहे. फायनल रिडिंग H2 या ठिकाणचं रिडिंग आहे. कॅपिटल H2, small h2 is final reading here. So H2, capital H2 minus initial reading small h1 जर आपण केलं तर आपल्याला या ठिकाणी काय भेटेल? H2 भेटेल, right? Or capital H, not H2, capital H will get here. So this is the column for that, H2 minus small h1. जर मला या ठिकाणी small h पाहिजे असेल म्हणजे हा डिफरन्स पाहिजे असेल, हा हेड पाहिजे असेल तर काय करेन मी? Small h2 is equal to h2 minus small h1. So we can see here. So this we will get here small h. h capital H minus small h हा आपण का करतो या ठिकाणी फाइंड आउट करतो कारण त्याचा जर आपण फॉर्म्युला पाहिला किंवा थेरॉटिकलचा तर त्याच्यामध्ये हा पार्ट त्या ठिकाणी आहे कॅपिटल H मायनस स्मॉल h म्हणजे कॅपिटल H इज दिस h अँड स्मॉल h इज दिस h. ह्याचा डिफरन्स हा आपल्याला फॉर्म्युलामध्ये लागतो, त्यामुळे आपण हा या ठिकाणी कॉलम ऍड केलेला आहे. झालं सगळ्यांचं? नेक्स्ट पार्ट इज अबाउट द कॅल्क्युलेशन्स. राईट ऑन देअर Q actual capital A into delta H divided by T meter cube per second, and this is the formula to find the theoretical discharge. H into L into under root of 2Z into, this is the bracket to complete. हा पूर्ण याला ब्रॅकेट आहे. Q theoretical is equal to H into L into under root of 2Z, where Q theoretical is equal to theoretical flow rate. Capital H is the upstream head of water over the weir crest. Small h is the depth of water, depth of flow over the weir. L is the length, width of the channel. Next, coefficient of discharge. CD is equal to the actual upon Q theoretical. Is it over? Next, C is equal to L into under root of 2Z. From the graph, we obtain the value of K and we find the CD for the verification by using formula CD is equal to K upon C. K ची व्हॅल्यू आपण ग्राफ वरून काढतो, C ची व्हॅल्यू आपण वरच्या फॉर्म्युलेत काढतो, आणि स्लोप n is equal to dy by dx. This is the log graph paper. On this graph paper, we can put these values. Log on the x-axis abscissa, log h minus small h, and on the y-axis, that is ordinate, log actual discharge, log QA. Here, this value will be negative. That's why this graph we have to draw in the third quadrant. Okay. What are the four quadrants? Which is this quadrant? This is second. This is third. This is fourth. Okay. In our Indian, we measure the quadrant in anti-clockwise direction, right? This is our first quadrant, second quadrant. Generally, whatever the graphs we plot, that are plotted in the first quadrant. Okay. This is the origin. X-axis reading will be taken here. Y-axis reading will be taken here, and we draw the line curve or any curve that is available. But as these values are negative, h ची value negative होते, h पण value negative होते. So x minus y minus another quadrant to play in. X value minus y value minus means this quadrant will be. So this will be the origin here. This point is origin. Values will increase here in this downward direction, and so this is the origin. इथून इकडे खाली आणि इथून इकडे रीडिंग्स आपल्याला घ्यायचे. ते पॉइंट ज्यावेळेस आपण प्लॉट करतो आणि ज्यावेळेस आपण लाईन ड्रॉ करतो, त्यावेळेस आपल्याला एक स्ट्रेट लाईन कर्व भेटतो. ज्या ठिकाणी हा पॉइंट प्लॉट करतो, दिस व्हॅल्यू इज कॉल्ड एज द के व्हॅल्यू. के ची व्हॅल्यू या ठिकाणी आपल्याला भेटते इथपर्यंत. ओके. आणि हा जो स्लोप आहे या ठिकाणी dy by dx. So n is equal to dy by dx. या ठिकाणी आपल्याला n ची व्हॅल्यू भेटून जाईल. Log graph paper we have to use to draw this diagram. Last one is the result table here. Next point. Serial number, actual discharge, theoretical discharge, CD, average CD, log QA, log H minus H, CD from graph. ग्राफ वरचा CD आणि आपण ऍक्च्युअली फाइंड आउट केलेला CD हा सेम पाहिजे. 1 year पाहिजे. Is it over? Conclusion. The coefficient of discharge of broad-crested weir CD is equal to, from the log graph paper, coefficient of discharge CD is equal to and slope of the line I is equal to. Is it over? So this was the explanation for this practical number 7, that is calibration of broad-crested suppressive weir. So I will perform this practical on this particular experiment. Okay.